All right. So Dr. Pajcini, are you here?
Yes, I'm here.
Okay, it's your show.
All right. So I'm Pajcini. Slightly change of pace from what you've been hearing right now. Most of our focus is on stem cell biology, but we have very active collaborations with Dr. Katani and also with Dr. Jawan Shin, who you just heard from. And we are very open to continuing these collaborations together to develop more bioengineering tools to study stem cells, and especially stem cells from the blood. So my lab is mostly student-oriented. I've had one student just defended last year, actually this year, and one will defend next year. And Killian's already doing biotech studies at Clade Biotech in Boston. Next slide, please. So the focus of our work is developmental hematopoiesis. We want to study where the the best stem cells of the blood come from. And we do a lot of microscopy to actually visualize them during the embryo development, where the stem cells form even before the heart starts beating. Then the cells migrate to the fetal liver, where they expand exponentially. And eventually they'll go to the bone marrow, where everybody knows blood stem cells reside on. But what people don't really realize is that the stem cells in the bone marrow are very dormant. They're very quiescent. You could see here what happens early on. The stem cells are actually still together in the bone marrow, and then as the organism matures, they become isolated. So a lot of the studies that are focused on the bone marrow studies for stem cells have been focusing on an organism that on an organ and a stem cell that doesn't divide very well. So we really want to focus on the stem cell expansion in the fetal liver. Next slide, please. So the way we do this is we use So the way we do this, we use transgenic mice to directly analyze molecular components that allow the cells to expand very rapidly. And this is a way in which we can learn the biology. And I'm hoping that one of you can come in and help us translate that biology into more bioengineering approaches, and in collaboration with other BME labs, develop ways to expand them. So the work that is done is to delete a specific gene, in this case, JAGED1, specifically in one cell type. This allows the loss of it both at the protein level as well as at the mRNA level. We can see that the stem cell numbers are not affected. The green cells here are all stem cells, and we know that the blood vessels are not affected. The red staining here is also the blood vessels. However, the functionality of the stem cells is affected by the loss of this one single factor. So it makes sense to see that if there's something that specifically, when lost, defeats the purpose of the stem cell to expand and provide us with blood, what if it is reintroduced and elevated levels? Can that expand the stem cells and thus provide us a renewable source of stem cells for use in the clinic? Next slide, please. So a lot of the work that we do is, if you want to work on mice, you want to understand stem cells, you want to learn transplant, it's what the work happens to harvest the fetal liver, harvest the cells, purify them by flow cytometry, transplant them into different kinds of mice, and then monitor the blood reconstitution. It's really translatable because the work means that as soon as you harvest the stem cells, you can follow their ability to function. And if you allow means for bioengineered ways to improve them, you can also track them along. Here's one way we rescue this defect. We have immobilized ligand. We take the stem cells that are from mutant mice, keep them together for 24 hours with immobilized ligand, and you could already see that the colony formation, stem cell formation is improved. And once the cells go through the bone marrow, they are fully reconstituted, and they can allow the blood to become fully relevant to reconstitute the mice. So a lot of the work here is a little bit different pace, but I think if you're really interested in the bio part as well as the engineering, or my lab would be a good way to actually meld the two together and create some really astounding work. So contact me, contact Salman, Dr. Katani for further information. Thank you.
Thank you, Costa. And as Dr. Pajcini mentioned, my lab has been collaborating with Dr. Pajcini for several years now in leveraging our engineered models for some of these hematopoietic questions. Obviously, blood is extremely critical for the body. So, you know, as I said before, the College of Medicine faculty and the College of Engineering faculty work really well together here at UIC. And so really, we accommodate BME students in labs from both COM, College of Medicine, as well as College of Engineering with the proper collaboration